Hi, we're going to take a look at this AP style motion problem, very typical in an AP question. So we have a model car that's moving along a straight line, moving forward. The velocity is given to us by a differentiable function v of t, and we have some selected values of the velocity at some point in time as given in the table. So the first question is to approximate the car acceleration. This is velocity. The acceleration is the first derivative. Right, so a of 3 will be v prime of 3. And how do we approximate that? We use 2 points that are close, 2 and 4 in our case. So we always have to set it up as a difference quotient, so it should be approximately equal. It's going to be v of 4 minus v of 2 divided by 4 minus 2. This is a difference quotient. V of 4 is 7, v of 2 is 5 divided by 2. And we're going to get 1. This is going to be in correct units, meters per second squared. Next thing we want to approximate the integral from 0 to 12 of the velocity using 4 subintervals with the right Riemann sum. So right Riemann sum means we're going to go like this. Right? The right end is what we're going to use. So the integral from 0 to 12 of v of t dt can be approximated as, so we're going to do 2 times v of 2 plus 2 again times v of 4 plus 3 from 4 to 7 times v of 7 plus from 7 to 12, that's 5 times v of 12. So 2 times v of 2 is 5, plus 2 times v of 4 is 7, plus 3 times v of 7 is 6, plus 5 times v of 12 is 10. What do we have here? That's 10 plus 14 plus 18 plus 15. And hopefully we don't mess up this simple mathematics here. This is 32, 42, 92. Now the question is, what does that actually mean? So we have an integral of velocity. Always think in terms of this. Velocity is, let's say in our case, meter per second times seconds. That is meters. Meters what? That's how far the car moved. So the car traveled 92 meters from t equals 0 to t equals 12 seconds. That's what it means. Next question. Is there any time t on the interval from 0 to 12 where the acceleration of the car equals 1/2 meter per second? Okay, let's take a look at the table that we have. We have this table of values. So from 0 to 12, what do we know? We can approximate the acceleration from 0 to 12. So what do we know? Since the function, the velocity function is differentiable, it says right here, then we can use the mean value theorem. Since v of t is differentiable on 0 to 12, it is continuous also on 0 to 12. Therefore, by the mean value theorem, there exists x equals, well, t equals c such that v prime of c is going to equal v of 12 minus v of 0 divided by 12 minus 0. And that actually happens to be, when you plug in the values, is going to be 1/2. So we know that by the mean value theorem we guarantee that there will be acceleration somewhere that's going to equal 1/2. So there exists a value t equals c such that v prime of c, which is a of c, is going to equal to 1/2. And the answer here is going to be yes, basically. And the last question. The car's position at t equals 0 is 3. Use the trapezoidal sum with 3 subintervals as indicated by the data. Find the position of the car at t equals 7. So what we're going to do here is we're going to realize that we use the integration. So what we're trying to do is we want to do x of 0 plus the integral from 0 to 12 of v of t dt. No, I'm sorry, 7. I'm only going to 7 here, right? So we know what x of 0 is, that's 3. Plus here we're going to use the trapezoidal sum. So we're only using this much. So it's going to be 1/2 times the height of the first trapezoid, which is 2, and 4 plus 5. Plus the second trapezoid is from 2 to 4, 1/2 times 2 times 5 plus 7. Plus the third trapezoid is from 4 to 7, 1/2 times 3 times 7 plus 6. This is the setup that will allow us to approximate the position, because this will give you the displacement of the car. All we need to do now is do the math. So 1/2, half, this will give you 9, plus this will give you 12, plus this will give us, so it doesn't simplify, we have 3 times 13, that's 39, 39 halves. Right? And all we need to do now is finalize this. So 1224 plus 39 halves. So it's 48 halves plus 39 halves. So this will be 87 halves. This is going to be the position of the car, approximation of the position of the car using the trapezoidal sum. Okay? Hope this helps.